Thank you. This is actually my second talk for Insomnihack. I was here last year. Who attended my talk last year? Oh, most of them are not here anymore because probably they need more copy. And so I hope you had a good copy for today. I put because you might need it at the middle of the slides. Ready? Okay, we are going to talk about mostly a ransomware named Petya. Have you heard of Petya? Yeah, anyone that knows Petya will know that it is have some sort of scare tactics and so on. But I'm not gonna focus on the attackers or how they do that. What I'm going to do is I'm going to look on how we can debug the boot process infected by Petya. Okay, so much for the, before we do the technical stuff, let's do some introduction. I work at Fortinet. That's what we had a sponsor for yesterday lunch. Okay, that's the vendor pitch. Okay, I published actually some articles in Bars Bulletin about malware research, and mostly I wrote articles also in our blog. Okay, those are some of my conferences. I made some like conference matrix. Mostly my profile pic is that guy, but when I do malware reversing, this is my joke last year too. It was actually I'm this guy deep inside. When you do like reversing, you're actually trying to look like Batman. Oh, I think it's not Batman. Anyway, okay, before we talk on the technical aspect of my presentation, we try to talk about some trivias. Okay, before, way, very long time ago, we used those things. Okay, anybody? Those are floppy disks wherein, okay, they're called floppy because they are kind of, you can actually bend them. Okay, and then, but before we have that, those are only, imagine you cannot even put an MP3 songs inside one of those things. But before we have games and everything, we have the operating system and so on and so forth. Okay, and IBM created a 1 GB hard drive in 1980. It is actually 75 pounds. Imagine if you wear that hard drive, okay, like if you have this 256 gigabytes multiplied by that one, imagine you probably cannot walk, or you cannot even fit them in your car. Okay, so those are the evolution of some of the our technologies. Now we can actually have like 5 terabytes and so on and so forth. Where one time when during my college years, so many years ago, okay, we went to a conference wherein we went to like exhibits wherein they showed us a matchbox size 1 GB. Okay, it's a very impressive technology, but now you can actually hold it in your keychain. Okay, but even though it evolves so much, they always have what we call track zero, head zero, sector one, which is the very first sector, even in floppy or hard drive. And if you are talking about the hard drive, we have what we call the master boot record. Even this one, they have the master boot record. It is always the very first sector. Okay, we have what we call now the UEFI that uses the GPT. Okay, GPT and MBR, they are kind of different, but in reality, they are still a physical drive. Okay, GPT has what we have, what we call the per sector is still what we call the protective MBR. It is still an MBR, but it is for just backward compatibility. Okay, MBR is the very first sector in a regular drive, hard drive. Okay, it uses the standard BIOS. GPT uses UEFI. Okay, but they both have the MBR. Okay, for the GPT, the second and last sectors holds the GPT headers. Okay, they are some sort of the replacement for the MBR. Okay, so we have the first sector is the MBR, protective MBR. The second sector is actually the GPT headers, and it is mirrored for the last sector. They are the same. Okay. Let's see now if we can create how to create a GPT and MBR in your Windows operating system using this management. Okay, you can see this. You can actually initialize a this. Okay, and then you can tell if you're creating an MBR or a GPT. Okay, you just have to click those buttons and so on and so forth. And then if in the meantime you want to change them, for example, you decided, oh, I'm going to use actually a UEFI or you're going to use the GPT, but you already have the MBR. Using the same tool, this management, you can actually convert them to GPT to MBR and MBR to GPT, the vice versa. This is this management, it is the tool that exists in Windows operating system, which most of you probably is not using because you're all Linux guys, mostly. Okay, for creating this partition, okay, the only problem that exists before, if you create a partition in MBR style, you can only create 4 specific partition. If you want to create more partition, it is now called logical drives. Okay, it is not directly a physical partition. Okay, something like this. Okay, if this one is your MBR, okay, you can only create 4 partition, and then this is actually one big partition, but it contains extended partition, which we call logical drives. But for GPT this, okay, you can actually have GPT and MBR that exist in one operating system, in one computer. Okay, you can actually create as much partition as you want. The limitation is the size of the partition, is the size of your hard drive. Why do we do partitions? Sometimes it is used to make accessing of your drive faster. But because of the advent of newer machines, newer computers, sometimes you don't normally create partitions in your hard drive. Even my computer doesn't have partitions. Okay, using this part, it is a command line tool. It just shows you, if you run that, it just shows you which these are GPT. If you have the asterisk, then it is actually a GPT. You just have to run this part. Okay, that's the only purpose of this part tool. Okay, let's go now to the structure of the disk. Okay, if you're going to use MBR, okay, we call each sector with the CH0, the cylinder head and sector. This one is actually the very first sector, and this one is the very first sector, also MBR, but we call them LBA, okay, instead of CHS. Okay, and there's some sort of computation basing up. If, for example, you're talking about MBR, which is the very first logical block addressing 0, and then the CHS is the MBR, and then so on and so forth. Just a different computation. But still, we are talking of sectors and we are talking of physical drive. Let's go now to the malware. Petya is a malware wherein, okay, it's like similar to different kind of ransomware. Okay, first, to avoid detection, it has to regenerate its executable image in the memory. Okay, it runs through this process. This set of codes are only decrypting a simple D word. It will go back, loop back, decrypts another D word, and so on and so forth until everything is decrypted to the memory. Okay, when we run Petya, okay, it checks for the MZPE marker to make sure that it is actually running the actual copy of itself. Okay, if you are going to look into the actual code, at first it tries to resolve its APIs that it needs. Okay, because hiding those APIs, it tries to hide from antivirus detection. Okay, that's why they try to resolve it later on after the decryption. Okay, and then these are the common APIs that it uses. Okay, basically, if these APIs are exposed, okay, your antivirus or security system can easily tag them as malicious by just the combinations of the API. That's why they usually hide them. Okay. Okay, Petya has this section. This section is very important. It contains this one, the ransom note. It contains the rest of the code. It checks the only decryption routine is only this one, XOR decryption. It is not very, very complicated. The complication goes when it runs on the BIOS. Okay, it looks for the bootable disk, okay, in order to put. What happens is when you run your Petya, you're in the Windows system, when you run your Petya, it will look for, if it has escalated privilege, it will look for your physical drive, okay, physical drive 0, this one, okay, and then there is the drive C. Usually the first drive, which is the drive C, the first hard drive, contains the MBR. If it is a GPT, it contains the protected MBR. Okay, what happens? This is how you read drive C if you want to do programming. If you want to read your MBR, you have to check first the physical drive 0, which is your very first drive. If you happen to have able to do a representation, or for example, you make your drive D as your physical drive 0, still, if you happen to have, if you want to access the very first drive, you have to access it using the physical drive 0. And you have to include device IO control API. Okay, it is wherein it is the one that physically access your physical devices like your hard drive. Okay. This is how it gets. It tries to check if what is your physical drive that represents the drive 0. Okay. It checks for the volume control, get volume disk extents and those structure. Okay, the initial call for create file A and device I control is just for checking if the malware can access. Because if you are actually doesn't have privilege, okay, the malware cannot access your drive 0. That means it cannot infect. Okay, if this first check is successful, it will now proceed on the infection. First, it checks for the physical drive 0. Again, that's the second time. Okay, for physical drive 0, for backward compatibility, it is also called DR0, DR1. Okay, for NT4, of course, is still again hard disk 0, DR0. Those are different ways to check or to name your physical drive. And to open that file, it is actually considered as a regular file. Your MBR is considered as a regular file, which is create file physical drive 0, and then call the device IO control later, right? You can actually use WinObj. It is actually another tool wherein you can actually tell which way your operating system is calling your physical drive 0. Are you still with me? Okay, that is WinObj. That's the tool. Okay, now this is now how the malware actually calls the physical drive 0. So it is calling physical drive 0, okay, by using create file and followed by device IO control. Okay, this particular code for the IO control, it checks if you are using MBR or GPT. Okay, why the malware needs to check if it is MBR and GPT? Because it will try to, if it is GPT, it will try to overwrite the very first, remember that GPT has the protected MBR, and then GPT headers from the front and at the back of your drive. So it will actually overwrite both of them, okay, later on. So this is how it checks. These are the informations. You can actually Google it. You can actually find it in the MSDN. Okay, using process monitor, it is another tool coming from sysinternals. You can actually monitor if your system, if your hard disk is being written to. Okay, it is using create file. I already cleaned this. It is using create file and device IO control. You can see that it is trying to access your physical drive. Okay, drive 0. And now the infection. The malware reads the MBR, sector 0. Okay, a series of instructions wherein it tries to encrypt your original MBR by just XORing it with 37, 0x37. The process is it opens the hard drive using create file. It sets the file pointer to a particular sector. Okay, read the file, that means reading the contents of the sector, XOR it opens it again, and then writes the encrypted version to your sectors. Okay, and followed by writing something or the new MBR, which is the malware kernel mode. And then after that, because one MBO, the MBR is only one sector, it is not enough to put everything else. Okay, so it is starting at sector 22, it will write the rest of the kernel code. Okay, or just for the MBR format, okay, this is the MBR. The MBR is actually the boot sector contains usually the 55AA to make sure that it is the MBR, and then the rest are contains this. Okay, if you have 4 partitions for your MBR, it will be written in the MBR format. Okay, but normally this one it will be overwritten by by the malware. Okay, but it is being copied. The original MBR or the protected MBR is also copied to a certain sector's for if you happen to pay for the for the ransomware. Okay. Okay, this is the checking. Okay, this is your process monitor wherein it tells you which particular offset is being written, being read, and everything, right? So using process monitor, this is the actual code that says the pointer, read the file, and then check for the markers. And this is now the process wherein the malware tries to encrypt your sectors and including the MBR. Okay, there's another tool, Hijacking. Okay, this is not the actual hacker that infects your MBR. This is another tool wherein you can download it online. I didn't include the link because I might give you the uninfected link or something. Download it in your own risk. Okay, the Hijacking, this is the tool. This is actually a snapshot of the code from the malware actually for this one. Okay, it is actually similar wherein you can actually read. Okay, you can actually read your sectors. You can read your physical MBR. You can read any sectors that you want, and then you can actually save it into a file. You can actually infect or destroy your own MBR. Okay, if you're explorer enough, you can write something here. You can load a file. Okay, and then you can actually overwrite your MBR. You can write any sector that you want. If you happen to have, for example, if you want to try this out, okay, do not try this in your own computer. You can actually go to your friend's house. In fact, just trying, right? No, just kidding. Okay, do not quote me on that. Okay, you can use the Hijacking. Okay, so from the Hijacking tool, this is the output. Okay, we read the MBR, we put it in a file, and then if you're going to compare the code coming from the Petya, they're actually totally the same. Okay, this is where it reads the code from your sector. Okay, this is now the code wherein I've told you earlier that it opens the file, read the contents, XOR it with 37. Okay, you can actually, if you have the sample, I'm not giving you the sample. If you happen to have the Petya malware sample, all you have to do is once it decrypts its code already in the memory, you can just search for this code. Then that is the start of the MBR infection. Okay, and then if you use at the same time while you're running, while you're trying to debug it in the what you usually do is you run your malware in a debugger. Okay, and then while you're trying to while the malware is trying to encrypt, you can run it. Do not run the whole thing all at once. Okay, you can run it instruction by instruction using a debugger. And then once it tries to do one sector infection, you can actually use Hijacking again to read the content. Okay, this is actually the content, which is now 37 is an ASCII code for 7. Okay, it is now, that means if you see 7 here, that means the original content are actually 0. If you XOR 0 to the 37, you will see just all 7s. Okay? And then it will continue. You can follow the infection actually using, again, process monitor. You can monitor by sectors. You can see this. Okay? The actual length of one sector is actually 0x200. Okay, hexa. 200 hex. Okay, so every time it tries to encrypt, okay, it encrypts your sectors. You can see, you will be able to see this. There are actually lots of things going on while it does that, because process monitor actually monitors everything. This particular version is actually the clean version already. Okay, this is for the presentation. But you won't expect when you run the process monitor, you will see those things. You won't see that one. Okay, again, comparing the code, it writes the new MBR. This is the old MBR. This is now the new MBR. The new MBR is actually coming from the malware code. It is written on the MBR. Okay, so this is now the content. Okay, you can see that the content of the new MBR is almost similar to the actual boot sequence. Okay, we will see those things later on when we do the debugging of the boot sequence. Okay, so this is actually you're now infected. Okay, the malware MBR. Okay, even though you have it doesn't matter if you have MBR style MBR in your hard drive or GPT. When you have the petya and infected your system, okay, it doesn't matter. They will both be infected with the petya. Okay, you'll be happy because you have now the malware. Okay, the thing is, if you run the malware, okay, in your Windows system, okay, you won't be able to see the ransomware or the ransom note first. Okay, it has to finish everything. Okay, you're looking at this. It is not actually doing encryption. Usually ransomware, when we talk of ransomware, it is encrypting files. Okay, but this one, it is just encrypting your sectors. Okay, so what happened is, after encrypting the sectors that it needs, it will copy the rest of the contents of the kernel code from the malware itself, starting to sector 22. So when you see this one, it is now writing something. Okay, it is now writing the rest of the kernel code from the malware, from the petya itself. Okay, so once it's done that, okay, so this is now I'm just showing you the other contents of the code. Okay, so now it copies so I'm using HD Hacker to show you the contents that's being written. This is actually the part of the ransomware, part of the splashing screen. Later I will show you what's going to happen. So now we have now the infected MBR. We now have the infected sectors. What happens after infecting the sectors? Okay, this one is showing the content of the onion address. I just put the asterisk here so you don't need to pay for me. So it's done. I already paid for it. Okay, that is actually the content of those links is actually at sector 36. Okay, this is now what happened. Once you are infected, so you have your Windows system, you double-click your malware, your petya, and then from the malware itself, okay, it will actually, again, escalate the privilege, okay, check the different privileges, adjust the token privilege too, and then it will issue this API. This API is actually the reboot, the reset of the system. Once everything is infected, once the malware code is already in the sector, because writing something in your sector, in your MBR, in your hard drive, will not be affected again the system. Okay, you have to restart the system. Okay, so the malware forces the system to restart. Take note, if you're infected, if you have the malware itself, until it restarts, okay, your only infection is the sector from 22, and you still have the rest of your files. Okay, if you want to clean your system, okay, all you have to do is to stop the infection, do not reboot the system if you are fast enough to know that you're actually infecting yourself or your neighbors with Petya. Okay, if you are fast enough, okay, you can actually stop the infection, grab the hard drive, put it in another computer, okay, and then try to scan the whole hard drive as a physical drive. And then you can probably have some forensic tools that can grab the files in your system. Okay, make sure that you have not yet rebooted or restarted the system. But once the restart's already triggered, okay, you don't have any chance of recovering your system. Okay, as I've said earlier, we are now going to do the debugging for your BIOS. Okay, there is a open source tool called BOCH. I call it Box. Okay, I don't know how they call it. It is actually an emulator. Okay, normally when you're doing like an IoT or CTF or something, you usually have an emulator. This one is an emulator. It simulates Intel x86 computer. You can also use Box, okay, if you want to run old computer programs that doesn't run on your Windows 7 or Windows 8 or something, okay. It can run those games, okay. It can, of course, debugs your MBR code, okay. We're going to use Box, okay. I'm not going to do it live because, of course, it doesn't work every time, right? Okay, so usually 7C0 contains the boot sequence, but before reaching 7C00 location in your memory, in your MBR, or the memory, okay, it reaches, based on the sample that I have and also the operating system that I use, okay, I use actually Windows XP on this one, okay, I step through 5 million instructions, okay, one by one. Imagine it took me a year just to go to 7C00. Okay, upon reaching that one, okay, I am now going to actually load. In a regular computer system, okay, when you run your system, actually the computer still doesn't know if you're going to use Linux or Windows, right? Okay, when you turn on your system, it doesn't know which operating system you're going to use. That means during the boot sequence, you don't have Windows API. During the boot sequence, you don't have Linux API. That means the only thing that you have is interrupts. Okay, so the malware actually put a kernel code wherein it only uses interrupts. Okay, the very first sector is loaded when the boot sequence started, when you reach 7C00. Okay, when it is now loaded, the Petya MBR is the one loaded because it is already infected, right? And then it will start the initial reboot. Remember that we actually, the Petya uses the reboot to initiate the actual malware code. Okay, this is actually the code that will be executed when the Petya system infected will restarts. Okay, let's talk about Box first. When you open Box, okay, this is actually I already opened the Petya. This is now the Petya code. It is something like a regular debugger. Okay, you can see your registers here. You can see the assembly code. You can see the memory dump. The only problem with that is it is not very interactive. Have you used OLI-DBG, Immunity Debugger? Okay, so those debuggers are interactive. You can actually, okay, whenever you run an instruction or whenever you step on an instruction, you will see the changes in the dumps. You will see the changes in the register. But this one, if you want to see the changes here, okay, you have actually to refresh this particular part, the dump window. But this one, okay, even though you're going to change this, you will only see some changes in the registers. It is kind of harder to execute, but it is fun because if you're debugging debugging an MBR, okay, you are just some of the few people that can debug the MBR because nobody wants to debug the MBR. I only tried to debug the MBR when I had this samples. It is fun. Okay, so you have this debug window, registers window, and dump window. Okay, of course, I've said we don't have yet the APIs. Okay, it only uses, if you want to transfer a value from memory to sectors and sectors to memory, you use interrupt 13 function 42. Okay, if you want to change screen displays and video mode, you use interrupt 10. Okay, this is how you read the sectors from the drive. Okay, it uses interrupt 13 function 42. Okay, and then we use something like we call DAP, this address packet. These are the informations wherein where to put that value, where in memory, how big is how many sectors, case being read, and so on and so forth. So initially, Petya's code is going to read this. It will read one sector, which is which is the Petya MBR. Okay, and then it will be executed. Okay, using interrupt 1342, it reads the contents of 200 bytes, which is the first sector from the 22. The 0x22 sectors contains the actual part of the Petya kernel code. Okay, this is what happens. It runs that code, and then it gets back the content. The only problem with debugging the MBR is you cannot really, the dump values are not interactive. Okay, you cannot put comments wherein you can go back, read the comments again. Okay, and then you need to constantly refresh the windows, code windows, the dump windows. Okay, this is now how it initializes the video screen. Okay, it uses interrupt 10. Okay, similar to API calling, you push the values. This one, you use registers to have the values. Okay, this is where it copies the MBR to a safe place. Okay, wherein if you happen to pay, you can actually get the actual MBR, but not necessarily. Okay, I didn't actually pay, and then you can get this content. Okay, whenever you, for example, it reboots, and then you want to stop the reboot, you reboot again. Okay, you restarted again the system. The malware knows if it is already encrypted the system. Okay, it has a certain marker wherein if it is 0, that means you're not yet infected. If it is 1, you're already infected. Instead, if it is 0, it will infect your system, and then change the flag. Okay, if it is 1. Okay, instead of encrypting the system, it will show you the flashing screen. This is now the initial display of the system. Can I pause this? Oh no, it doesn't pause. Okay, it will try to show you something. Are you familiar with the check this? It is like a utility that actually try to scan your system for errors. Okay, so what Petya did is it copies the style of the system. As you can see, okay, the box system is actually gave you this screen. It is actually the screen. It is emulating your system. Okay, and then on the right side, it is actually running the display. It is calling interrupt 10. Okay, to display each of the letters for this thing. I'm just showing you how it is being executed in terms without the APIs, only the interrupts. So interrupt 10 is for the display of the screen. Okay, you can see that it is actually almost the same copy or the same way check this is actually executed. The only problem with that is, okay, once that particular screen display started, it will now start encrypting your system. Okay? Petya ransomware does not encrypt your files. Okay? It encrypts your MFT. MFT, the master file table. MFT, each file in your system is actually has a header, okay, like a metadata. Okay? That header or metadata is actually contained in the MFT. So each content in the MFT is actually, what happened? It restarted. So the MFT contains data for your file, but it doesn't have the actual file, just a pointer to the file. Okay, so Petya does not encrypt the files; it encrypts the MFT. So if you're infected, you won't be able to access your files because the header itself is encrypted. So that is the initial display. So this is now the checklist. Okay, so the checklist, the one that displayed earlier, is actually looks really similar to the fake checklist. Okay, now after showing that fake checklist, it will check the content of 36. Okay, it checks for the marker. If it is 0, as I said earlier, okay, that means it is not yet encrypted. Then it is now going to encrypt your MFT. Okay, it reads the current content of the location. Okay, it will actually compute the number of sectors that contains the MFT. Okay, after computing that, this is actually the view of MFT. Okay, look at this NTFS. This is actually the content of your NTFS. Okay, so in the MFT, okay, it is actually in the NTFS boot sector. It contains at least one entry for every file. Some files they have different or more than one entry. Okay, so what happens is the malware computes the number of sectors that contains the MFT. Then after initial display, okay, it is actually going to show you something that it is like checking the disk. Okay, once this particular part starts counting, that means it is now encrypting your MFTs. Okay, that percentage is actually real. It is not just the show. Okay, it actually computes this particular numbers is actually the number of sectors that has the MFTs. Okay, it actually computes the actual MFT, and then it encrypts those things. This is what I'll show you. There's a video demo that will show you how it actually. Okay, this is the call wherein it will try to read the contents of your MFT and then encrypts it. Okay, they are all in box. They are all, okay. It is just using a simple computation. Okay, it is now starting the sector 2 out of the 32,000 sectors. Okay, refreshing this again. I just have to keep. So this one is actually a sample of an entry in your MFT wherein it represents a file. Okay, starting with this. And then after the encryption, there's the encryption part. And then, of course, you have to refresh again. Okay, as I've said earlier, that everything that happens, you have to refresh because it's not very interactive. It is now the content of the MFT. It is now encrypted. Okay, it will now keep encrypting your system. Okay, until it's reached 100%. The only problem is if you got scared once you see this, okay, and then you stop in the middle, okay, and then you decided to pay the ransomware, okay, what will happen? Okay, if you happen to pay the ransomware and then you happen to have, just for, in theory, you get the decryption code, and because you stop in the middle of the encryption, the malware will tag it as encrypted. So 50% is encrypted, 50% is not. Once you get the decryption key and then you execute the decryption routine, that 50% encrypted will now be decrypted. The 50% not encrypted earlier will now be encrypted with your decryption key. You see the irony of the you now pay for actually the encryption of your not encrypted files. Okay, so that is now the encryption routine. Okay, so when it happens, if you went to your neighbor's computer to trying this out, and then you have to make sure that everything is encrypted. So you have to make sure that it is 100% encrypted, because if you try to make sure that you want to do it again, then, or you want to load the encryption or the decryption routine, then you have to be sure that 100% encrypted. Okay, and then after the encryption, again, okay, the malware still is not showing the ransomware node. It will trigger another reset, another reboot. So the first reboot is from the malware code, okay, a reboot API, anti-race hard error or something, and then it will trigger the encryption when it executes the BIOS or the MB or the kernel mode, and then it will now actually trigger the second reboot. Okay. During the second reboot, it initializes the video screen. Okay, it reads sector 0 and checks for the encryption marker. And because it doesn't matter if you encrypt 50% or 100%, it will be tagged as encrypted. Okay, and then if it is encrypted, it will now show the ransom note, which is, okay, this is how it actually generates. Okay, again, the display is using interrupt 10. Okay, and then it is now showing some graphics. Okay, it's like an ASCII graphics, because you don't have yet the other APIs that generates the 1080p graphics and so on and so forth. So those are actually just an ASCII display. The one that scares people is actually just an ASCII display. It is being executed. See, I am actually following the actual code being that particular part is being generated. Okay, the ASCII that is the ASCII skull. Okay, it is now going to do some flashing. Again, it is using a normal interrupts. Okay, because you are just running the code, okay, in your BIOS. So you can see that is how Petya actually encrypts your system. So whenever it if you tries to reboot the system infected with Petya, it is actually just checking if it is already encrypted or not. If it is, and then you're going to actually have the ransomware node. Okay. Again, I removed oops, I clicked the wrong thing. So somewhere here, okay, I tried some of the combinations, and then because you are in a debugger, you can just jump somewhere, okay, going for the checking of the code, and then put my name there as a key, okay, because I just tricked the system that it is the actual key, and then it will actually, if you have the actual key, okay, it will actually run the decryption similar to the encryption earlier. But this one, because I just tricked the system that it is the actual key, it is not actually decrypting the system. Okay, my MFT is still encrypted. And then now, once it decrypts, it thinks that it decrypts your system, it is now asking you. It doesn't actually reboot itself. It is now asking you to reboot your system, because it thinks that you now have the decrypted system. Okay. The only problem with Petya, another problem with Petya infection is if you're infected, if you're a regular user at home, you're infected, okay, you only have one machine. There is no way to go online and pay for the ransomware, right? You have to go again to your neighbor. That's why you have to infect the neighbor system so that you can use your other system to pay, right? If you're working in an environment wherein you have machines, different machines, you can infect the system, other system, you can use the other system to pay. Okay. Luckily, there are different versions of Petya. We have the not Petya. I think Bad Rabbit is also some sort of Petya and so on. The malware author gave away the master code. Okay, if you're still infected with Petya, okay, you can actually use the master code. That's what they said. I haven't actually used that. And actually, if your machine is already infected before, and then you just already reset the system or reformatted it, so you will not be able to use the decryption code. We're done. For Pinale, okay, stage 1, Petya infection has different stages. Stage 1, it copies the MBR mini kernel code to the hard drive, initiates reboot. Stage 2, it displays the fake checklist, encrypts your MFT table, initiates the second reboot. Okay, it displays when it restarts, it displays your ASCII skull and now waits for Bitcoin payment. Okay, I don't actually suggest paying the ransomware. You know why? If they know that when you are infected and you pay, they will keep infecting you. They will tell the other ransomware authors to infect you because you pay, right? That's why never pay. And these are some of the tools that I use: the risk management, Oli debug, x64dbg. Okay, if you have a malware version which is 64, Oli cannot debug it, so you can use the x64dbg. Okay, I have the WinObj, process monitor, Hijacking, and of course our debugger, the emulator. And that's it. Thank you. Any question? Who wants to infect their system? I'm not giving away the sample. Question? Oh, you're sleeping the whole time. Come on. Question. We have 2 minutes. Or you're hungry already. It's lunchtime, right? After this. Come on, I came all the way from Vancouver and then you're not asking questions.
No questions? Oh.
Oh. I'll give you a copy later.
So I guess that Petya doesn't encrypt your MFT with a key that it stores in the hard drive. So like, does it encrypt it with a public key, and then when you purchase the key, it's a private key that you can use to decrypt or something like that?
You're asking if the key is installed in your hard drive?
Yeah.
No, it's not installed in your hard drive. That's why you have to go to the Onion address, and then they will give you the key. You will give them the code.
So it's a private key that you purchase?
Yeah.
Okay.
Question? There is a way in which, for this particular version of the malware wherein, because it is only encrypting your MFT, if you have time, you can actually use forensic tools wherein it can just brute force your hard drive and then grabs your file. You can actually do that too. Oh, that's your question? See, I can read your mind. So that is supposed to be his question, but we can just brute force the drive. Yeah, see. Any other question? I can read your question. Anybody? Okay, that's it. Thank you very much for your time.
Thank you very much, Raul.